On this RAM 1500 with the 3.6 P0073 means the PCM is seeing the ambient air temperature sensor signal too high or effectively open. In plain language, the outside temperature input may not look believable to the module. The MIL may come on, the outside temperature display may be wrong, and systems that use ambient temperature information can be affected. The broad fault areas are the sensor connection, the signal circuit, the sensor ground or return circuit, the sensor itself, and only after the wiring and connectors check out, the ECU side of the circuit. This is a two-wire temperature sensor circuit. Temperature sensors are typically a variable resistor that functions as a normal two-wire 5.0-volt sensor, and the ECU supplies the temp sensor with a 5.0-volt reference signal and a filtered ground return circuit. As a general rule, a voltage reading above approximately 4.9 volts would set a circuit high or open fault, and a voltage below approximately 0.10 volts will set a circuit low fault. For the monitor's normal set points, the circuit low threshold is typically in the 0.1 volt range, and the circuit high threshold is typically in the 4.9 volt range. Also confirm where the ambient sensor is on the exact vehicle build before testing, because the sensor location can vary, including the grille area or mirror housing. Before getting deep into circuit testing, start with the basic system checks. Look for any service bulletins, known cases, or ECU flash updates that apply to this code or symptom. Check the ECU for battery voltage-related codes, because low system voltage can create false direction. If other codes are present, check what they mean first, but keep P0073 focused on the ambient temperature sensor high or open circuit path. Diagnose circuit faults before rationality or performance faults. Then inspect the sensor connector before unplugging anything. Make sure it is fully seated and locked. After that, disconnect it and look closely for water intrusion, pushed-out terminals, spread terminals, corrosion, burnt terminals, or damaged terminal fit. Next, scan the vehicle and record the codes, captured operating data, and a scan report before clearing anything. Review the captured conditions and the monitor and set conditions, then erase the codes and operate the vehicle or system under similar conditions. If P0073 returns or the symptom is present, continue into the circuit diagnosis. If it does not return, treat it like an intermittent. For an inactive code, use the captured conditions to give the diagnostic a fair chance to run. If the conditions are hard to duplicate, check whether the failure mode is actually present before chasing the circuit. Treat the running conditions as monitor gates, not as a parts answer. Circuit low and high faults run with the ignition on and battery voltage above the calibrated threshold. The related performance monitor runs with the ignition on after an 8-hour cold soak on the previous engine off cycle, with ambient air, intake air, and engine coolant temperature values above -64 degrees C, -83 degrees F. A performance style comparison issue is typically not within 10 degrees C, 15 degrees C, 18 degrees F, 27 degrees F of the other engine temp sensors. For an intermittent P0073, check for related flash updates and bulletins before going further. If none apply, wiggle test the harnesses that carry this circuit while watching for the code to become active or for the scan data to change. The preferred method is to put a scope on the temperature sensor signal circuit and watch the pattern while moving the harness. If you cannot watch the scope live during the wiggle test, set a trigger to catch the fault. For this high or open fault, set the trigger for voltage above 4.9 volts. If you are also watching the low side of the circuit behavior, the low trigger is below 0.1 volts for a circuit low fault. Also confirm battery condition, battery connections, the related chassis grounds, and every component, module, and inline connector in the circuit path. If you have the electrical test lead kit, connect kit, electrical test lead 2,064,100,081 to the temperature signal and sensor ground circuits at the temperature sensor harness connector. Move the switch between open and closed while watching the scan tool. In the open position, the circuit high fault should set and the voltage should be 5.0 volts. In the closed position, the circuit low fault should set and the voltage should be 0.0 volts. That open and closed response is a quick way to prove whether the ECU and the two circuit paths can react correctly. Then move the switch to adjust and vary the resistance while watching the ECU signal voltage on the scan tool. If the open and closed tests work exactly as expected, the ECU and the temperature sensor circuits are testing good. At that point, the sensor is most likely faulty or has a poor connection at the sensor harness connector, so inspect that connector again before condemning the sensor. If a resistance table is available, measure the sensor resistance and compare it to the table. The actual resistance can vary +/10% from the table values. If the signal is stuck high, or only the circuit high fault sets, think open circuit or very high resistance in either the temperature sensor signal circuit or the sensor ground circuit. With the tool switched closed, if the scan tool still shows voltage present, move the ground side test lead to a good chassis ground. If the voltage drops to 0.0 volts, the resistance is in the sensor ground circuit. If voltage is still present, the resistance is in the signal circuit. Check the correct circuit for high resistance. Typically, it should be less than 3.0 ohms. If the circuits check good, inspect all related connectors for pushed out, spread, corroded, or dirty terminals before condemning the ECU. If no connector or circuit issue is found, ECU replacement is supported by the diagnostic path. If you are using conventional voltage testing, make sure the temperature sensor and ECU harness connectors are connected and locked before backprobing. Turn the ignition on and measure the temperature sensor signal circuit at the sensor harness connector. If the signal is between 0.1 and 4.9 volts, the sensor signal may be a legitimate reading. If the fault is active and scan tool voltage does not match the meter, the ECU is suspect. If the signal is a constant 5.0 volts that points toward an open farther downstream, most likely the sensor or the sensor ground side. If the signal is above 6.0 volts, look for the signal circuit shorted to another voltage supply. If the voltage test directs you into more circuit isolation, disconnect the temperature sensor and ECU harness connectors and check the temperature sensor signal circuit for high resistance and short to ground. If that signal circuit checks good, inspect all connectors in the system for pushed out, spread, corroded, or dirty terminals before condemning the ECU. To check the temperature sensor side, move the test lead over and backprobe the temperature sensor ground circuit at the sensor harness connector. For the typical circuit low path, disconnect the temperature sensor harness connector while watching for the circuit high fault to become active on the scan tool. If that high fault does not become active, disconnect the ECU harness connector to isolate the circuit. Then check the temperature signal circuit for continuity to both chassis ground and the sensor ground circuit. Now focus on the typical circuit high check for P0073. Disconnect the temperature sensor harness connector and measure the signal circuit voltage with the ignition on. The signal circuit voltage should be between 4.9 and 5.6 volts. If battery voltage is present, repair the sensor signal circuit for a short to another voltage supply circuit. If that voltage is correct and the fault is active, watch the scan tool and jumper across the connector terminals with the ignition on. Typically, the temperature sensor signal voltage should change to 0 volts on the scan tool with the jumper in place. If voltage data is not available, the circuit low fault should set with the jumper in place. If that response happens, the temperature sensor is faulty. If the response does not happen, check resistance in the temperature sensor signal circuit and ground circuit. Typically, the circuit resistance should be less than 5.0 ohms. Repair an open or high resistance in the circuit. If both circuits test good and the high fault is still present, check every connector in the circuit path for water, terminal spread, pushed out terminals, burnt terminals, corrosion, or dirt before condemning the ECU. If no issues are found, ECU replacement is supported by the diagnostic path. If the problem is acting more like a performance, rationality, or Intermittent temperature sensor issue. Use the test kit to separate the wiring and ECU from the sensor. Disconnect the temperature sensor harness connector and connect the electrical test kit leads to that harness connector. Move the switch on the tool to open. The signal should read 5.0 volts and a circuit high DTC should be active or pending on the scan tool. Then flip the switch to the closed position. The signal should read 0 volts and a circuit low fault should be active or pending on the scan tool. If there is voltage present between 0 and 5.0 volts with the test tool in the closed position, that points toward resistance in one of the circuits. Remove the test lead connected to the temperature sensor ground circuit and connect it to a good chassis ground to decide which side has the resistance. Then confirm the suspect circuit by isolating it and measuring resistance between the sensor and ECU harness connectors. If no resistance is measured, carefully recheck the connectors in that circuit path for spread terminals or dirty and corroded terminals. If the circuit response points back to the sensor, confirm it instead of guessing. If a temperature table is available, move the switch to adjust, connect an ohmmeter to the test leads, dial the tool to a resistance value in the table, connect both leads to the temperature sensor harness connector with the ignition on, and monitor scan data for the proper reading. You can also use the tool to vary resistance while watching temperature or voltage on the scan tool. When an actual ambient temperature can be acquired or reasonably estimated, measure resistance across the sensor terminals and compare it to the table. Use the table values as checkpoints. -40 degrees C/40 degrees F/345. 26 k ohms is the lowest possible temperature reading. -10 degrees C/14 degrees F/53. 38 k ohms is in the logical temperature values. -5 degrees C/23 degrees F/40. 89 k ohms. 0 degrees C/32 degrees F/31. 56 k ohms. 5 degrees C/41 degrees F/24. 55 k ohms. 10 degrees C/50 degrees F/19. 24 k ohms. 15 degrees C/59 degrees F/15. 22 k ohms. 20 degrees C/68 degrees F/12. 13 k ohms. 25 degrees C/77 degrees F/9720 ohms. 30 degrees C/86 degrees F/7780 ohms. 35 degrees C/95 degrees F/6370 ohms. 40 degrees C/104 degrees F/5200 ohms. And 150 degrees C/302 degrees F/181 ohms is the highest possible temperature reading. If the measured resistance is not in range for the table, the temperature sensor is likely faulty. If a temperature table is not available for the sensor being tested, connect the electrical test kit leads to the harness connector. Flip the switch to adjust, turn the ignition on, and slowly adjust resistance while watching scan data. The temperature or voltage value should change as resistance changes. To verify an ECU failure, open and short the circuits while monitoring signal voltage and fault codes. If the expected voltage readings or fault codes do not occur and the circuits are not shorted or open, that points to a faulty ECU. Before condemning an ECU, carefully check all connectors in the circuit path for water intrusion, spread terminals, pushed-out terminals, burnt terminals, or corrosion. The temperature sensor is individually serviceable, so if the sensor fails the resistance check, replace the sensor itself and not a larger assembly. Keep verification separate from the testing. After an ambient temperature sensor wiring repair, sensor replacement, or BCM connector disconnection during testing for an active code, the vehicle must be driven for a minimum of 5 minutes above 15 mph to update the AAT temp signal before the code will go stored and can be erased. The same update requirement is also stated for the temperature signal. The vehicle must be driven for a minimum of 5 minutes above 15 mph to update the temperature signal before the DTC will go stored and can be erased. Then rescan, clear the stored code when allowed, and confirm P0073 stays gone under the same type of operating conditions that set it. The takeaway is simple. Prove the 5.0-volt sensor circuit. Prove the ground return. Load the circuit with the correct test method, and do not condemn the sensor or ECU until the connector and wiring checks are clean. For more diagnostic training, visit stepdiagnostics.com.